The Waste-to-Bio project is implemented in Greece by the National Technical University of Athens in collaboration with the municipalities of Aspropyrgos and Papagos Cholargos, and its main aim is the production of second-generation ethanol from the sustainable management of household biowaste. The project is co-funded by LIFE, the financing instrument of the European Commission for the Environment. In the framework of the project, an innovative biowaste management pilot system was set up in the partner municipalities. In specific, half of the participating households dried their biowaste at home using domestic dryers, while the other half of the households simply placed their biowaste in specific outdoor bins in order to be collected and transferred to NTUA for drying. Next, the dried biowaste were sent to the pilot ethanol plant, which is installed at NTUA. The ethanol plant consists of three parts: the pre-treatment reactor, where the dried biowaste are subjected to the necessary pre-treatment with the addition of specific enzymes; the main bioreactor, where ethanol is produced through alcoholic fermentation; the steam boiler, which is used to supply the entire process with steam. The multi-criteria analysis software tool Waste2Bio MCA, developed under the Waste2Bio project, aims at the comparative evaluation of the alternative municipal biowaste management methods based on economic, environmental, technical, and social criteria. The Waste2Bio MCA is a particularly useful tool supporting the decision-making process for the management of biowaste at local, regional, and national level. At the same time, the tool is also suitable for general use, as it can be used by anyone who is interested in exploring the performance of each method or combination of methods against the examined criteria. The biowaste management methods which are evaluated with the Waste2Bio MCA tool include all methods applied at full scale in Greece and worldwide for the treatment of source-separated biowaste, such as the composting and anaerobic digestion methods, as well as the management methods of non-source separated biowaste, such as the landfilling and the incineration method. The evaluation also includes the process of biochemical conversion for ethanol production, which was developed under the Waste2Bio project. The assessment of the waste management methods is based on the life cycle analysis approach, as it takes into account the whole biowaste management system, from the production and transportation of waste to their treatment or disposal and the exploitation of the potential products. The data used in the tool database are adjusted for Greece where possible. The multi-criteria evaluation method used is the weighted sum model. The Waste2Bio MCA tool is user-friendly as it requires basic computer use skills. The operation of the software does not require any installation, merely the existence of the MS Excel 2007. If the program is running and the commands are not enabled, a safety warning at the top of the screen will appear. Pressing the Options button, a new window appears. Choose the option Enable this content and click OK. The program consists of a main menu with 5 options. The first window is Introduction. In this window, the user can read some basic information about the software and its structure, as well as to find links to the online tutorial video and the user manual. By left-clicking the button General Data Scenarios, the user is directed to the second window, where he or she may import data for the production, collection, and transportation of biowaste and financial data, as for example the selling price of the potential products of the different waste management methods, that is, fertilizer, electricity, and so on. If the user is not aware of some values, default values may be selected. Also, in the same window, the user can create up to 8 biowaste management scenarios. Each one of them may include one method or a combination of methods which will be evaluated by the program. If the user wants to create a scenario, he or she can click the Configuration button, which leads to a separate window for each scenario. In this window, the user can choose the biowaste quantities for each alternative method. For some of these methods, the user may define a specific type of management. Overall, 8 specific methods are modeled: open window composting, enclosed composting, anaerobic digestion with energy production, biochemical conversion to ethanol combined with domestic or central drying, incineration with energy production, and landfilling with biogas flaring or with energy production from biogas. For example, the user here types the quantity of biowaste which is to be directed towards anaerobic digestion, while the rest of it is directed to landfill. Here, the user may also type a text providing a brief description of the scenario. For anaerobic digestion, there is no subcategory. However, concerning landfilling, the user is called to select among a landfill with biogas flaring and a landfill with biogas exploitation for the production of electricity. Finally, the key features of the scenario can be noted in the comments field. Once the configuration of the scenario is finished, the user can click on the back button to return to the General Data Scenarios window. In the same way, the user can configure the rest of the scenarios. In order for the program to work properly, the user must enter at least 2 scenarios. By clicking the Criteria button, the user is led to the Criteria Weighting window. For each criterion, the user enters the score he considers it best represents the significance of the criterion. If the user enters the value 0 for a criterion, then the criterion will not be taken into account in the multi-criteria analysis. If the user enters the value 100, it is indicated that this criterion is very important. Depending on the rating of each criterion, the final criteria weighting changes. These changes appear in real time in the diagram at the right of the window. By clicking the button Weighting, the user is led to a window in which he has to grade each alternative in relation to the criteria selected. More specifically, for each alternative method and for each criterion, the user enters specific values such as the price in euros per ton of installed capacity, the price in euros per ton processed, the impact on ecosystems, and so on. The criteria technical maturity and security, social acceptance, and job creation are qualitatively evaluated with a use of a scale ranging from 0 to 100. Alternatively, the user may select the copy price option and enter the default values of the program database. By clicking the Results button, the respective window opens. In the field Scenario of the criteria, the user can either choose the weights which were previously chosen in the criteria window, or select a default scenario which assigns higher weighting to the environmental or technical criteria. Finally, the user can select the weighted scenario which assigns equal weights to all criteria. In each case, the final weighting of the criteria is presented at the diagram on the left. If the user wishes to change the weight of the chosen criteria, he or she can select the user option in order to return to the criteria window to change the weights accordingly. By clicking the Results button, the user returns to the Results window. In the Ranking Scenarios field, the final ranking of the defined biowaste management scenarios are shown. The results are presented at the diagram on the left. In the field Detailed Results, the classification of each scenario is presented along with a thorough description of each case. The user may also conduct a sensitivity analysis of the results. By selecting the option Sensitivity Analysis, the user may change the environmental, technical, and economic criteria weighting and see in real time how the ranking of the scenarios changes. Additionally, the user can increase or decrease the price of bioethanol in order to observe how the final ranking of the scenarios is affected. In the case where, while increasing the weighting of one criterion, the weighting of another criterion is decreased below 0, the program displays a warning message for the user in order to readjust the weights. Finally, the user may print the results by clicking the Print Results button.